increases to 200 kPa. At what temperature will propanone boil at? So what will the boiling point of propanone be if the air pressure is increased to 200 kPa? So air pressure is increased to 200 kPa. What is the boiling point? What is the boiling point? I'm just going to put BP of propanone. So that could be a Regents question. So I don't have room up here. I should have picked the pressure I could fit it on here, but whatever. What would the boiling point of ethanoic acid be? If you really understand what's going on, you can answer that. All right. What do we need? Well, propanone. Increase air pressure to 200 kPa. What would the boiling point? So back there, what we did was we lowered the air pressure to about, let's see, if water is what, the third line? Yeah, so water is this line right here. So what we did, we boiled the water, it was somewhere, let's see, 25, 30, 35, 40, 45. So it was boiling right around 40. Okay, so there's 40 degrees. So water is here. So the air pressure in that vacuum chamber back there was somewhere around like 8 kPa. That was around 8 kPa because water was boiling at 40 degrees. So I want to know what's the boiling point of propanone if we're here. We're at 200 kPa. 77. Who agrees? Most people? Good. All right, so let me see here. I screwed this up because it's hard to read. All right, so we're down on this line here. Let's see if I can do that here. Yeah, so about, yeah. So 76, 77 degrees. Very good, very good. Good job. Okay. What about ethanoic acid? Mike, what would ethanoic acid boil at 200 kPa? It's a trick question. It wouldn't boil. Not according to this chart. Why? Yeah, we can't get up to 200, okay? The line would keep going up probably, but it's not charted. So it would probably be all evaporated at that point, right? So it would be all evaporated already. Or I mean, sorry, it wouldn't be able to reach it, sorry. So if this line, dotted line, was moved up to 200, this probably would never actually get there, right? It would be under that, except maybe really, 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 really high temperatures. So basically, here's the things you need to know about Table H. Weakest forces, strongest. As we move this way, how to read vapor pressure, and then if we move the air pressure line, these types of questions, you make the air pressure lower, boiling point drops. Air pressure higher, boiling point goes up. Remember, if something boils, what's happening, we drew this yesterday or the other day, your vapor pressure pushing up is equal air pressure pushing down. So if you take away the air pressure, the vapor pressure is gonna win, it's gonna boil. But if you add more vapor pressure, it has to be, more air pressure, it has to be hotter to push up against it. That's why the boiling point goes up when you increase pressure, and then it goes down when you decrease pressure. Okay, so, no, if the air pressure drops, then the boiling point drops. And if the air pressure increases, the boiling point increases. I think I said that right. As long as you have it straight. So the boiling point for all four liquids will decrease. The lower the air pressure, that dotted line will be down here somewhere. And if you increase air pressure, boiling point goes up. And remember, boiling points are dependent on what? What dictates boiling points? Tyler. How come this desk won't boil, but water can?
Because the forces of attraction
are weaker in
liquid.
Right, in the water compared to this desk. Right. Okay, moving on. We're done with Table H. Kind of beat that to death. Hopefully you're good with that. All right. Where are we? We are done talking about liquids. So your homework, don't forget the back of that worksheet and specific heat capacity. Word of the week. You kind of missed it last week. So define that, put it on your homework or with your homework tomorrow. All right. Moving on. We're good with that. All right. The only thing I want to mention now, we talked about gases, we talked about liquids. Real quick about solids here. So solids, we know solids vibrate. We know they have definite shape, definite volume. What happens at the melting point? So melting point. Oops. So at the melting point, what happens to solids? It's not a hard question. They melt. Very good, Tyler. So at 0 degrees Celsius, H2O solid will be in equilibrium with H2O liquid. So we just talked about boiling, and when liquids boil, especially if it's in a closed container, we talked about how H2O liquids will be in equilibrium with H2O gas. Right, so at 100 degrees, and this happens if it's not boiling, but if it is boiling, this is also occurring. So at 100 degrees for boiling, we have liquid and gas going back and forth. We talked about it if it's in a closed container. If it's in a closed container, this can happen, whether it's evaporating or boiling, but that's equilibrium. Well, if ice is melting and it's in a sealed environment or a closed environment, so there's not a whole lot of vapor going on there, this is also happening. So you have equilibrium here between solid and liquid. So let's just write that down. Equilibrium. Equilibrium between solid and liquid. So what's the freezing point of water?
32.
Celsius. That's Fahrenheit. What is it?
0 degrees.
0. So what's the melting point of ice? 0. How can it be the same? So the melting point and the freezing point are exactly the same point. Someone explain. Both of those things are happening at the exact same time. How can you have freezing and melting at the same point?
Solids are melting and liquids are freezing.
So it depends on what you start with, right?
Yeah.
So if you have an ice cube, temperature goes up, it hits 0, it starts to do this. If you have liquid water like in here, and you drop the temperature by removing the heat, cool it down, it starts to do this, starts to freeze. So, but I can't stress this enough, at 0, so stuck at 0, both are happening at the same time. If you go to 1 degree, what phase is gone? What phase is gone? Solid. So 1 degree Celsius, we have all solid. I mean, all liquid, all liquid. What if this goes to negative 1 degree Celsius? Then you have just ice, the liquid is gone. So at 0, you always have both. Anything above it, this is gone. Anything below 0, this is gone. So that's it. Solid's kind of boring, not a lot to talk about. And that leads me to introducing the next thing, which we're going to do in lab. Who has lab today? Period 8. Okay, we're going to come in here, and then we're going to go down to library and graph. We'll finish up that lab today. So next lab for everybody. So it'll be probably not till Wednesday for today's lab, and then Thursday for tomorrow's labs. You're going to be, it's kind of like a lab, more like activity than a real lab. We're going to be learning about this. I don't really spend too much time in class on it. Phase diagram. Phase diagram. Oops. I didn't spell. Phase diagram. What's it sound like? What's it sound like it shows? Phases on a diagram. Exactly. I'll show you a picture. Here we go. And I want you to copy this into your notes. And then that'll be it. The bell rings, we'll pick it up tomorrow. Oh, great. My link doesn't work, so I'll just Google it. Oh, it's little. Technology. No, I don't understand. Ah, there we go. There's a good one. Okay, copy that down. Again, the bell, if it rings, we'll pick up at this tomorrow. So that's called a phase diagram for water. It looks like a Y, kind of. Okay? So you kind of got a line that does this, and a line that does that, and a line that does that. we'll talk more about it tomorrow. I will be after school. If you need anything, don't forget your homework.